Hello guys, today in Energy is Live, we are going to discuss what the efficient steam utilization and energy saving opportunities in the process industry. So, why is this topic important? You see, if you lose steam, means if there is a steam leakage for a hole as small as 3 mm, it can cost you around 192.7 thousand kgs of steam in a year at a pressure of mild 7 ksc, and it is even much more at higher pressures. So taking the minimum cost of steam of production in India, that is 1 rupees 23 paise, it can cost you a whopping 2,37,000. So it is very important to understand the efficient utilization of steam and to prevent steam leakage. You see, first of all, you need to check your steam traps. There is a condensate discharge from the steam trap, and the steam trap should be working properly, and there should not be any flash steam or leaking steam. Now, what is this flash steam? You can easily identify it that if a steam is coming out intermittently in a whitish cloud form, so it means that it is a flash steam. And what is a leaking steam? If a steam is coming out continuously in a blue stream out of the steam trap, then it is a leaking steam. In both the cases, the steam trap needs to be replaced or it needs to be repaired, and you need to follow the OEM recommendation for that. Now, whether you should use a dry steam or a wet steam. Now, best steam for any industrial process heating is dry saturated steam. Wet steam is actually a mixture of steam and water having a dryness fraction less than 90%, you can say, and due to the high water content it reduces the total amount of heat which can be carried in the steam. On the other hand, superheated steam, that is the steam at a temperature higher than its boiling point, it gives up heat at a very slow rate because the actual amount of heat energy transferred at a very fast rate is when there is a phase change. When the steam converts itself from gaseous state to the liquid state, that is when the maximum amount of heat transfer takes place. But if the steam is in its state only and only the temperature is decreasing, then that steam then the transfer rate is very slow. So hence the best strategy is to use steam at exactly its boiling point at a given pressure with maximum dryness fraction. In order to increase dryness fraction, any process industry may use the cyclonic type separator or coalescence type separator as well. Now, when you are using the steam, what should be the ideal pressure of steam? Studies show that the latent heat of steam reduces as the steam pressure increases. Hence, it is best to use steam at the minimum pressure possible. But you cannot decrease the pressure to a very low value, because lower the pressure of the steam, lower is its temperature, and hence the temperature difference between the product and the source will become lesser and lesser, and hence the amount of heat transfer will be lesser. So the best approach in this case will be to select the lowest possible steam pressure with which your equipment can work without sacrificing on either production time or steam consumption. Last but very important is to minimize the barriers to heat transfer. Most commonly, we can see that there is a scaling on the surface of the pipes, which affects the amount of heat transfer between steam and the product to which we want to transfer heat. So for this, regular cleaning of the surface both inside and outside of the pipe is important, and elimination of formation of any film like a water film or a condensate film. If it is formed inside or outside the pipe, then it affects the transfer of heat. Moreover, proper air venting is also crucial because air is a very good insulator. So you must need to ensure these things in your industry in order to ensure that you are making the maximum use of the steam, the costly steam which you have produced in your plant. Now, after the steam is utilized, so condensate is formed, but what to do with the condensate? You can throw it away, but it is not. What should be your strategy? You see, when the steam is converted back to its water phase by transfer of heat, it still contains around 18% to 30% of its heat energy. Hence, it is highly beneficial. So you can use it for the financial reasons, like the condensate which is formed from steam is pure water, and which it can be again used to generate steam and transfer the heat. So you don't need pure water from the other sources. Moreover, the high temperature effluent is very detrimental to the environment, so there are effluent restrictions. And the third thing is the fuel savings. So higher the temperature of the water already available, lesser is the amount of fuel you need to spend to again heat it to the boiling temperature. So, and one more catch is there, you can even recover flash steam from the water if your process allows for the steam. And we may discuss it in some later video. So thank you very much, guys. Thank you for your patient hearing, and do like my channel. Bye bye.